All right, dude, we are live. What's up, guys? This is Dem Keys, and we are starting off the stream with some frame rate, some frame rate issues. So just give me a couple of seconds to let this stabilize. It doesn't seem to be stabilizing. Uh, okay, okay, yeah, we should be good for at the very least the next hour, I guess. Hopefully we should be fine. What's up, guys? This is Dem Keys, and today we are going to be continuing learning. I want to say continue. Oh shit! I started the stream and I forgot to change the title. I could change the title now, but then that's not gonna update the VOD title, so I'm gonna have to change the VOD title later as well. Or is it that it holds on to the latest title and not the previous title? No, I think it holds on to the previous title, not the latest title. Um, let's just say even more. There you go. Just there just needs to be a difference between yesterday's and today's stream title. That's about it. Okay, now between yesterday and today, I have been reading up on blanket implementations, trying to understand. Um, well, I mean, I've understood the concept of blanket implementations, and it's really interesting to me. I wanted to understand how I can find out, like for any given trait, how can I find out what blanket implementations exist? Um, Additionally, I also want to see if for any given type, how I can find out whether blanket implementations exist. Because, like, for example, um, if we if we continue with our previous thing, which was from and into, basically the idea is that if you um, if you implement from on if you implement the from trait for a given type on a given type, then for that, how do I say this? Because here there are two types. Here there are two types that can be used. Oh, actually, it's no, it's for a given type in a generic struct. I believe so. Anyways, if you implement the from, I'm trying to think of how to say this. I guess the best thing I can do is like show it. Over here we have some trait O1. I made this as a blanket. This is a blanket implementation, so I need to show you a proper implementation. Let's create struct my struct O2. Doesn't need anything. Then no, actually, I think no, it doesn't. I don't think it needs anything. Yeah, I don't think it needs anything. I don't think I don't think so. From for my struct O2, right? Hopefully I've done this right. Is that okay? Conflicting implementations. Do I have a my struct O2 somewhere here? For this one, I can understand what the issue is. I just need to create a my struct O2 and pass that out. What's the issue here? Conflicting implementations of trait from so-and-so for type so-and-so. From T for uh wait, no, back up. It's supposed to be I'm supposed to pass in a type here. Yeah, yeah. And then over here, I need to pass in that type as well. And then now we have, um, now in a situation where I'm trying to do, let's say I'm trying to create a mystruct o2 variable, because I've done I32. So now there's a blanket implementation of into for I32 that can return my struct o2. This is what I was trying to say, but like I'm not able to get the right vocabulary there, because what it is we are implementing the from trait for my struct o2, but we are implementing the from trait with I32. So that with part, I'm not sure how to say it exactly. But yeah, when we do create this kind of an implementation, then what this does is it creates a blanket implementation for any I32, where, wait, it creates a blanket implementation of the into trait for I32 where the expected result is a mystruct o2. So here we have a variable that we have created that is expecting a mystruct o2. We have explicitly type annotated it. And so if I now use into, this is valid syntax. This is not valid syntax. Let me just fix this thing. I was just testing something out here. Um, let's go to this. Okay, okay. Yeah. So yeah. Here you can see this is valid syntax. It's not throwing any errors, and in the hover info, you can see it says that it calls from. We didn't need to implement the from trait. Sorry, the into trait. We did implement the from trait. We didn't need to implement the into trait. The into trait has a blanket implementation for from, and we can see that over here. I don't remember if I opened up from. I think I did somewhere over here. I'd opened up from. Give me a second. Let me just, I can open up from over here real quick. I'd opened it up yesterday, and then I think I closed it. So I'll just open it up again. So Rust from, and I also learned how to figure out what exactly is considered a blanket implementation when I'm reading the docs. Hold on. So, as an example, if I am looking at, well, you know what? We're looking at the from trait. They also have the into trait here. And fortunately, they mention over here that this is used to do a value to value well, what I'm trying to show you is that they mentioned that there's an implementation. I'm going to read the entire thing. Used to do value to value. Hold on, did I switch away from BRB? Yeah, I did. Used to do value to value conversions while consuming the input value. It is the reciprocal of into. One should always prefer implementing from over into, because implementing from automatically provides one with an implementation of into thanks to the blanket implementation in the standard library. This is where our blanket implementation comes in. Only implement into when targeting a version prior to Rust 1.4 and converting to a type outside the current crate. From was not able to do these types of conversions in earlier versions because of Rust's orphaning rules. See into for more details. All right, okay. So we're going to look at into. This is the into trait. So Okay, okay. I think. Wait, the stream disconnected and restarted because it's in OBS. It's showing the number of frames just like restarted from around zero. Um. Okay. Yeah. I don't know. I don't know what happened. We. I guess we had a bit of a crash. Fortunately, the stream didn't end, so I don't have to stitch anything. But yeah, okay. Getting back to this thing. So there's two sections here. I'm going to show you the last section first because that's the section where I understand what we're supposed to be doing. Hold on, where was that? Down here, implementers. Why was I not but words? Oh my god. Why was I not seeing implementers? Implementers is here. Okay. So, implementers is where we'll be able to see which types implement this trait. Um, if there are types that implement certain traits by default, like if you look at from and go down to implementers, we can see a bunch over here. There's a bunch of implementations, a lot of them for path and OS string and regular string and a string slice, C string, ASCII char, and a bunch of. There's something called cow. I don't know what this is. Um, but yeah, there's a bunch of implementations here. In addition to this, I don't know if it mentions over here. Oh God, this is a long list. Holy shit. This is, oh wow, this is a very long list. Let's look here. It does mention the into thing here. From so and so for you implies into you for t. I need this kind of vocabulary. This is what I need to understand because this is there in into as well. Um, Wait, what is cow? The type cow is a smart pointer providing clone on. Oh, it's clone on write COW functionality. Clone on write. Drawn Blood, hello, hello. Welcome to the stream. Thank you for redeeming Pride Hearts. I unfortunately don't have that working right now. Um, I could fire up. I haven't fired that thing up in a long time. Happy Pride, by the way. I should set up something else to do Pride Hearts. But yeah, welcome to the stream. Hello, hello. How's it going? Sad no hearts. Yeah, yeah. I need to work on something for that. It's just that this current version of my VTuber application, I'm gonna be kind of revamping it. I'm gonna make a more let's say terminal based version, and then at that point, I'm gonna work on some more aesthetic things. Right now, we are going through. Hold on. My browser seems to be a bit frozen. Yeah, okay. Right now we're just going through the documentation for the from trait and into trait in Rust. And more specifically, I'm trying to understand the whole blanket implementation thing. Because when you implement from for for a specific type, but when you implement it on another type, it's hard to explain. It's hard to put that into vocabulary. Like, okay, here I have my struct o2. For my struct o2, I've implemented from, but I've implemented from um, for the I32 type. So it's not for just any type. And because of this, because of implementing from for I32 for my struct O2, anytime there's an expectation of my struct O2 type, I can then use an I32 type, so a 32-bit integer type, and I can call the into function, the into method, to return a my struct O2. This was interesting to learn. This was interesting to find out. Actually, I'd first seen it in, I think it was in the validation section. I don't remember. I think so. I think when I was writing validation code, that's when uh that's when I what was it returning though? No, no, it was for an invalid validation. So if it was for the invalid variant of the validation enum, that's where we would be using into. And it turns out when you have a closure that takes in a string slice and return. So okay, this learning about how to discover blanket implementations, it has helped me in various ways. One of them being, if I now look at where is it? Am I looking at string validator? Yeah. So if I look at string validator and I come down here, we can see blanket implementation. This basically means that anytime we pass in a closure, or anytime we have a closure that takes in a string slice and returns a result with validation and custom user error type, plus this clone thing. I haven't really looked too much into that. Whenever we have this type of closure, that can be considered a string validator. So that's why we were able to pass that closure, because I was initially confused about why we are able to pass in a closure into where's that function, into with validator. Because if you look at the signature for with validator, it says v, well here it doesn't say it, but like if I call it separately, because here I've already passed in, you know, oh wait, I could remove val, and now, yeah. So if you look here, it says um, with validator is, it's a generic function. It's expecting a closure, which is a generic type, but that has a trait bound of this string validator. And I was confused as to how the closure that we are creating, how that closure is considered a string validator. And it turns out that is thanks to blanket implementations. In this case, this is a blanket implementation, which allows us, in a way, I guess this is something similar to, would this be considered something similar to into? It's not exactly the same thing, because like one is a trait, but like, I mean, into is also a trait, but like with into, the idea is that we are implementing from, and that blanket implements into, and because of that we're able to call into, which then returns the type that we need. But in this case, we are, thanks to the blanket implementation, we are able to satisfy the trait bound, which is string validator. But yeah, yeah, it was good to learn how to, read these different types of implementations. I feel like now in the future, when if I ever come across like a different type, and I look at the docs, at least this section is going to be a lot more clearer for me, a lot more clearer than it was before. Um, Hold on. I'm gonna continue reading the the conversation I was having with Gemini about um, about reading this vocabulary. Hold on. There's this kind of vocabulary from so and so, specifically whatever is mentioned in generic implementations. So I need to go into the into. I can close this, and here, yeah, sorry, sorry, zoned out. Um, so here we also have a generic implementation section. So what I'm trying to do is I'm trying to understand how to read this exactly, and Gemini was explaining to me how I'm meant to read this. Wait, sorry, I'm just looking for the conversation. Parsing arguments, okay. Closures, syntax, okay. Rust closures as trait implementations. Where was that conversation? Um, Here, okay, okay. Where did I put that conversation, dude? Now I have to search for it. Explain the generic. Oh, this is it. Okay, all right. When you look at the into documentation page, the generic implementation section is essentially a convenient cheat sheet for a quick directory, no, or a quick directory of blanket implementations. Here is exactly what that section is doing, why it's separate from the bottom of the page, and how to read it. So the bottom of the page is implementers, which is here. This part always gets me confused because this doesn't actually lead to anything in the page. This is leading to something else. I need to look into that. But yeah, in implementers, under the implementers section, you can see where there's a blanket implement or what blanket implementations exist for the into trait. It mentions here that there's a blanket implementation for the into trait in or for the from trait. I was also discussing with Gemini about the vocabulary because, like, while I understand what exactly is going on here, I understand the fact that, okay, the way that the standard library has set up both from and into makes it so that anytime we implement from on a type, into will be implemented for that type as well. And as a result of that, we are able to call, you know, a specific type dot into. But like because there's two type when I say type, that can be confusing here because there's two types um there's two types in this. There's so if we look at if we sorry, I zoned out for a bit. Where was I? Yeah, if we look at this, the from implementation that we have here, we are implementing the from trait on mystruct o2, right? However, from is a generic trait. From does take a generic type. So we have to pass a concrete type to it. So there's two types at play here. We are implementing from for I32 for my struct O2. So I'm trying to understand how I would be saying that in a sentence. Give me a second. Okay. Um yeah, let me continue reading what Gemini was saying. So in terms of vocabulary, what Gemini said is the most accurate way to say it would be into has a blanket implementation for any type that implements from. Um, Apparently, this is the most precise because you are implementing the trait into for a generic type T under the condition where that under a condition under the condition that another type implements from. Actually, yeah, okay. If I look at this, it says impl so and so into for you for T, where U is from T. So into is being implemented for T. T in our case would be an I32. Yeah, yeah. T in our case would be an I32, and U implements. Okay, so what we have here is we have into um being implemented for U, but the U here I believe is our type my struct O2. Let's look at the into implementation here. Yes, so U is my struct O2 and T is I32. So that's kind of interesting. We've implemented from for my struct O2, but then into is being implemented for I32 instead. Yeah, that's an interesting switch happening there. Okay. Um, Continuing reading what Gemini was saying. What is the generic implementation section? Think of the documentation page as a breakdown of who gets to use this trait. The top slash middle explains how the trait works. The implementers section, which is the bottom, this is the literal source code declarations of every concrete type and blanket implementation that Rust compiled into the library. The generic implementation section, this is a high level summary that says, hey, look here first. These are the major sweeping rules that automatically grant this trait to whole categories of types. Okay. Instead of forcing you to scroll through hundreds of individual types to find the blanket rules, Rust docs group these all-encompassing rules together right under generic implementations. How to read the lines in that section. If you look at the generic implementation section on the into page, you will primarily see two major entries. Let's translate them from compiled speak into plain English. Okay, let's come up here in generic implementations. The from link. Well, okay, this is so the thing that Gemini is showing me right now is let me go into the Scratch buffer. Yeah, what Gemini is showing me right now is this. Um, this thing. And this is basically the blanket implementation of into for T. Um, in this case, T is I32. Give me a second. Let me hydrate. Okay, so what it means, this is the exact blanket implementation we just talked about. The docs repeat it here at the top because it's the single most important rule for into. It's telling you you don't need to manually implement into for your types, just implement from because this generic rule covers it. The reflexive implementation, self to self, that is impulse so and so for T. I think, hold on. I think I need to copy the text so Gemini can see it because I feel like Gemini doesn't see it right now. Let me copy both of these and paste it here. Hey, so just to be clear, these are the two lines I was talking about. That's this and this. These are the two lines under the generic implementations section um, in into. Okay. Um, right. You are looking at the exact absolute core of how into behaves. Let's demystify. All right, fine. Line one from so and so implies into so and so. Oh, dude. Okay, hold on. It's making sense to me because we just discovered that switch thing, right? Where with our from, what we are doing is we are actually implementing it like this. From T for U. So in this case, we have implemented um, from from I32 for my struct O2, right? So it's saying here from implemented in this way implies that into is implemented in this way. So if we make sure that the U and T always point to like very specific things, if U is my struct O2 and T is I32, then implementing from I32 for my struct O2 implies that we have implemented or implies a blanket implementation of into my struct O2 for I32. That's what it's saying. That's what it's saying. Okay. So given an I32, we will then be able to return a my struct O2. So the actual implementation of like returning from I32, that is being created through the blanket implementation. All we have to implement is from. Now this is making sense to me. So anytime I see a line like this is essentially a blanket implementation. This is what a blanket implementation would mean, right? That makes sense. Let's see if it's a similar thing over here. Where is it? Okay, I don't think we have that section here. We have implementers, but We do not have a generic implementations section. It just says trait implementations, and then there's implementers. So it's not mentioned. Um, I think according to Gemini in like later versions of the Rust docs creator, that's where they added this section. So maybe this is just older documentation. Dude, I haven't tried generating documentation nearly as much. We did learn it. We explored the creation of like the automatic creation of documentation, generating docs. We explored that while learning Rust, but then I didn't really use it after that. To be fair, I haven't worked on nearly as many projects in Rust as I would like to. I haven't done a whole lot of now that I have my GitHub workflow set up, I'm going to be doing a lot more finished projects, a lot more a lot more I don't want to say finished because there's a bunch of them that I'm going to be constantly working on, but yeah, quite a few of them they are meant to be like, work on it, set up the tools that need to be set up the tools that need to do very specific things and then just leave it as it is. I'm not supposed to constantly be changing the code. At most, if there's something that needs to be changed, I could put it in, sorry, I could put it into like a toml file, so I can set up the program to read that information from a toml file in case if there's ever a need to change data, remove data, add data. I can set up a thing where it's going to read from a toml file, so I can then keep adding stuff to the toml file. And massive advantage, I recently learned toml, so I should be able to set that up relatively easily. Um, I'm actually going to be using that for one of my projects. That project is going to be um, it's a dot files creator, dot files, not even creator, not even a generator. It's basically supposed to be a program that reads dot files, config files from various directories. Like NeoVim has a bunch of config files. Tmux has a config file. Westterm has its own config file. Bunch of other programs have their own config files, and I need them for my purpose. They're customized. A lot of them have customizations that are specific to my workflow and my preferences. So I would much rather have a backup of those files, but they are all in like different locations. So what I want to do is I want to create a toml file that lists out all of these directories from which I'm supposed to pull files or entire directories, and then it's just gonna, copy all of that over to the repo's working directory. And this is how I'll be doing my backup. It's not supposed to be copying back, like it's supposed to pull from those directories. It's not supposed to, you know, push to those directories. So I don't think I need to worry about the logic for that part. But yeah, let's let's continue reading. Okay, so line one, so and so, so and so. This is the documentation's way of explaining the automatic symbolic relationship between the from trait and the into trait. Yeah, I can see that. I can see that here. I can definitely see that being a thing. Or how should I say this? I I kind of get that from reading this. It took me some time to connect the dots. Like reading this sentence, it took me some time to connect the dots that what it's saying here is that, you know, um, when you implement from for I32 or from on, when you implement from, um, I still don't know how I'm supposed to say that. But yeah, okay, okay. My understanding is still there. It's basically when we are implementing from of type I32 for my struct O2, implicitly there is an implementation of into on my struct O2 for I32. That's what this line is saying. The next line, from is reflexive, which means that from T for T is implemented. I didn't understand this part. I'm gonna have to see what Gemini says about this. Let's continue reading. Uh, the word implies is the kicker here. So implies over here. It means you only ever have to do half the work. If you implement from in one direction, the Rust compiler automatically creates the matching into implementation in the opposite direction for you. That is actually a very good way to put it. If you implement from in one direction, then the compiler automatically implements into in the other direction. Sorry, zoned out. Okay, a real world example. Think about string and string slice. The standard library has this rule. String implements um, from string slice. So you can create a string from, oh, wait, that's basically from str, isn't it? Like, is that the blanket implementation? Hold on, let's get rid of a bunch of this stuff. Um, let's say, I don't know, str01 equals string from str. No, this is not from, this is from, this is from. Hold on, does this mean that I could do, if from str is being implemented, so does that mean that I could do something like this? ABC dot into. Yeah. Okay. Yeah, that's what it means. I'm guessing we are not seeing any diagnostic errors. Yeah, we're good. We're good. And if we look here, it says the same thing. Into U from T. T in this case is the slice because into is being implemented for T, and what this returns is U, which is a string. That's crazy, dude. Holy shit. Dude, this is okay. I feel like I'm going to be using into a lot more now. Now I need to look into where all into implementations exist. Cuz like could I do something like, okay, this might be a bit of a long shot, but let's see if this works. So let's say hold on, let's leave this as it is, and let's say sum01 equals, did I create something named sum01? No. Equals I32, and what I'll do here is do 6 underscore F32 dot into. Is there an into implementation? Hold on, there's a, no. No, there isn't. I was wondering like, okay, it's accepting what I'm typing, and that's why we have this. But then like, hold on. Wait, this is a different kind of implementation, isn't it? Does this mean that I32 does not implement from? I wonder, hold on. If I go to from here, how do I quickly go to I32? Okay, let's try this. I32. Primitive type, module, redundant constants. No, I think I'm just looking for this. Right. Okay. Implementations. Do we have, okay, there's methods, trait implementations. Do we see from over here? C, D, E, F, from. From, they have from implementations, but none for F64. They have from implementations for if, let's say I made, okay, what all do we have? We have a U8. So let's say I made an unsigned byte. That would work because there is an implementation. And now you see the proper, like what we're supposed to be expecting, what we're supposed to be seeing here. Now you actually see the blanket implementation. All right, all right. Okay, we are learning stuff. We are learning stuff. Also, apparently there's a from str, input from str for so and so. Would from str take, no, okay. I'm glad that I got to see, because I was wondering, okay, if it says from str but there's no generic parameter here, is it just that there's no generic parameter, or like is the generic parameter listed somewhere else? Okay, from str, let's give that a try. Let's do, so into is not gonna work, right? Into is not gonna work. How do I use this then? Okay. Um, right. Give me a second. Um, okay. All right. Okay, so let's read. Wait, they've given an example. They've given an example here. So there's I32. All right. Okay. That's not gonna work though. Well, that's not okay. Um, this should work. It's gonna fail though. Let's do print line. Do that, and It's some O1. Yeah, let's just let's print that out. Oh, it panicked because of the unwrap. But yeah, we know that there's an error there. It also mentions invalid digit. Okay, guys, I need to end the stream here. Unfortunately, I started the stream late, so like we can't stream longer. I would have gone for a little longer, but then I do need to end right now. Drawn Blood, thank you very much for stopping by and hanging out. Anyone else who might have been lurking in the chat, thanks for hanging out. But yeah, I think that's gonna be it for today's stream. Um, give me a second here. Just gonna, yeah, yeah. You know what? We haven't rated Louise in a long time. So we are gonna go hang out in Louise's stream. Louise is chill. Louise is cool people. Um, let's let me set up the raid. Oh, good. Okay, okay. She's got her break time right now. I think. I don't know. Or maybe she just got done with the break. I don't know. Either way, I'm gonna set up the thing and we're gonna go hang out in her stream. Okay, so that's gonna be it for today's stream. I'm gonna stream again tomorrow. I'm gonna continue reading about this off stream because I'm very much interested in the whole, generic implementations thing. And hopefully I'll finish this before tomorrow's stream. I'll move on to Clap as well, and hopefully finish Clap as well before tomorrow's stream. Let's see. Let's see if that happens. But yeah, dude, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.